So to bring this full circle, we'll get rid of the cross-section in the geology overlay and just look at the raw topography again, and hopefully now you have a better sense of what is going on structurally to control the outcrop patterns within this area. Of course, the very closely spaced and lower elevation ridges, or at least lower topographic relief ridges, around Franklin, West Virginia are associated with the very close and sort of small-scale buckling of the Silurian and Devonian rocks. That produces a bunch of really small folds. Erosion has etched those small folds out, and you get a bunch of closely spaced small ridges as a result. Likewise, the very broad synclinal structure that's associated with the outermost folding in this area has brought high section rock down to the same structural level as much deeper and older material. That high section rock has been deformed into really broad folds, and that makes very broad and high plateau structures. So there's certainly no coincidence as far as why this looks like it does when you think about it in structural terms. Now, in terms of overall elevation, why are those plateaux 4,800 feet above sea level instead of 2,800 feet? That's a bigger question that speaks to the long-term evolution of eastern North America, and there's a lot of questions remaining about why elevations remain as high as they do here, why the topography is so rugged, but certainly the form of the topography and where topographic highs and lows are located is very much a result of lithologic resistance to erosion and the structural patterns that deform those lithologies and expose them at the surface as a result of the prolonged erosion of this Appalachian tectonic wedge. Now, there's a certain amount of practice, I guess, and just time being spent looking at Google Earth topography to even train your eye to really see zones of high topographic relief, and you just have to spend time with the program to develop that skill. But it's a very powerful tool, and of course it's even more powerful when you can combine it with those overlays that allow you to see topography and how that is controlled by bedrock geology. Now, if we jump back to Google Earth real quickly, if you were on the ground in this location, as I mentioned earlier, it would be really, really tough to appreciate the overall structural context that you see here. For example, looking here at one very small fold structure within that Silurian and Devonian interval, can't really tell if this small anticline continues, I suppose, based on the pine tree growth. These are Virginia pines that like to grow on these sandstone cliffs. You can imagine this being a fairly upright fold, and you can see both of its limbs there. Down here we have a farm, houses and barns. You can see cattle in this pasture. If you were standing here, this would be a very large mountain to you, 980 meters at the summit, 760 meters in the valley, 220 meters there. You're looking at something like 730 or 50 feet or something like that. So this is topographically going to be fairly impressive from the valley, and you might be able to resolve the outline of the limbs of these folds from the ground. You'll certainly be able to see this cliff line, but that's still going to be very big for you to fully appreciate from the ground here. You can make your way back towards the hinterland, see all these stripes of dark pine trees that are growing on resistant sandstones. Here you've got fairly consistent dip within this section. In this area it looks like you've got some kind of fold structure. There is certainly an outline of it, I guess you'd say, based on that pine tree growth. Is that actually the case or not? I don't know. You'd have to look at this in person, but certainly the vegetation suggests that. And again, if you were standing in the valley, you might be able to appreciate that, you might not. It's still going to be really, really big. And that same situation is going to apply really, really anywhere you are. If you're in one of these valleys and you're looking at these topographic highs that are controlled by the outcrop of particularly resistant sandstones, which in this area have been deformed into these fairly small scale folds, it's just going to look like mountains. Now, you could cruise around and thoroughly map this region, and by moving many tens of kilometers, taking good data and synthesizing that data, particularly if you're looking at unit thicknesses you could produce a good map here, and you might be able to project those units down into the subsurface and eventually come up with a very detailed cross-section like you saw in the example from the Kuelander and Dean paper. But that takes a long time. That is a very large scale project, and certainly having access to Google Earth and the geologic map overlays puts in your hands and at your control a very, very powerful tool to take a look at this area, understand why the surface looks like it does, and also understand what is underneath you, which is of interest for a variety of applications. Of course, the Kuelander and Dean paper, I think, was largely from a hydrocarbon exploration standpoint. But if you're working in hydrology, soil chemistry and agronomy, anything like that, it's worthwhile to be able to understand the distribution of lithologies and how topography intersects with that. So this is just one example in one part of the Appalachians. If we zoom out to the larger scale and incline the view yet again, it becomes apparent that that outcrop pattern changes both north and south of the location we just observed, and associated with those changes are changes in structural style. And everywhere you go, the structural style is a bit different, but using the techniques we've seen here, you can already begin to try to understand that on your own without ever even setting foot in these locations. So give this a try. If you're watching this video, you've got internet and you have access to Google Earth and of course those overlays. So it's a very useful and very interesting interface, and it might be useful not only in your work, in your studies, or just if you're interested in knowing a little bit more about why Appalachia looks like it does today.